Oh, hi. Welcome. Our next lab experiment is on density, and density, as you know from the lecture, is determined by dividing the mass by volume of an object. It is simply defined as the concentration of mass of a substance. So if you know the mass, you know the volume, you can determine the density of an object. There are two ways of determining the volume. It's either through calculation or through volume. This experiment, it is a simulation. It is not in the lab manual, but I do have the handout on Canvas, which you can easily download that. Let me just share my screen here, and I'll walk you through the experiment, what you need to do, what you need to record, and where to get the data sheet. As I said during our first class meeting, there will be weekly modules under the um, module tab on Canvas. So right now, this is where I have week number 2, week 2, or experiment number 2. You will download all the files, all right? You'll download all the files in module number 2. If I expand this, you can see what I do have here. Here is just the background. Here is the simulation. The demonstration is right here, and here is just the background on Khan Academy, more about the density. You can log in there and watch more videos or demonstration on how to determine the density. The data sheets, data sheet can be accessed under the assignment. You need to come here and download, all right? Download the data sheet for experiment. Of course, for your case, you will not see all these are made available as we get along, but for now, this is where you need to come and download the data sheet for, no, this is pre-lab. I meant to say the data sheet for the lab experiment. These are pre-lab, so you need, this is what you need, all right, data sheet, that's what you need. You will download the document. Please take note of the due date 3rd of September. But if you get done before then, that's fine. So here is the data sheet. I'm just gonna download this and walk you through on how you will feel, how you will collect the data for experiment number 2. Let me just minimize this, and uh, I will load the simulation. I'll load the simulation under the module. So this document here, I'll recommend you may want to print it down before you start the experiment and have scratch papers, all right? Have scratch papers. There are 3 substances or objects. You will determine their density. Geometrically shaped objects. There is the pennies, there is the spheres, all right, the cylinders, spheres, and you'll also have unknown liquids. We have liquids here, all right, colorless, blue, and stuff like that. And the pennies will be the last item you will collect the data. So this is the data sheet you see here, which I'll recommend that you print, download, print, and have before you so that you collect the data from the simulation. So what I want to do now is load the simulation under the modules. This is where you need to come, okay? And I think you'll not see all the simulation I have for the rest of the semester. They are not available right now. You can read more under this tab. I don't want to get here, but this is the experiment. This is the simulation. If you see this window right here, don't say that I don't see it. Please come and click this side. I'm just gonna click that. And here are the substances you will be working with. Of course, you know from our lecture, from the theory, density is given by what? Density is given by mass of volume. And remember the units, grams per centimeter cubic, or sometimes this could be grams per ml, grams per ml. It turns out that, oh, sorry, I can't see for some reason, I don't know why, I don't see my, I need to do something here real quick. I can't see my, my whiteboard. On whiteboard here, you should see. I need to make sure that you are able to see. Hold on, excuse. So what I'll do is, I wonder, I check this and reconnect. Make sure you can see. Yes, this is what I was talking about. You can see my whiteboard. This is my whiteboard. And here is what I was saying, that density can be expressed in grams per ml or grams per cubic centimeters. Turns out that 1 ml, all right, 1 ml equals to 1 centimeter cubic. You should know that. So all the substances, you determine their densities. You'll make use of this equation. If you know the mass, you know the volume, you should be able to find the density. You'll start off with from the data sheet. You'll start off with geometrically shaped object. If you look at left, middle, right, all right, this has to do with what we have on the simulation. This is the left. This is the this is the left. This is the center, and this is the right. Based on what you see here, let me just load one more time. Here, left, middle, and right. It has to do with this. If I blow up this, or just left, this is left, this is middle or center, and this is right. It corresponds to that. So if you click here, it will give you the information you need. This is the mass, all right? And you will find the dimension, all right? You'll find the dimension using the scale given. The scale given on the measurement right here, the dimension, so that you use the formula to find the density of that equation. Again, my whiteboard is not responding for some reason. Let me just see if I can reconnect. Make sure you can see my whiteboard. So if I have that, for some reason this is reconnect. I'm gonna stop sharing the screen for a minute and try to reconnect again, see if it's going to work. You'll bear with me. Just quit. I'm just gonna quit the real time fast so that I can reconfigure the screen. I'm trying to connect my whiteboard, at least show you equation, which I believe you already know. Equation of straight line, equation of how to use formula to find volume of an object. All right, so here is my whiteboard, and if I know the rectangular, all right, so if you know the dimension, volume is given by length times width times the thickness, and remember the units will be in cubic centimeters. Please pay attention to the uncertainty in the sense that if you look at one subdivision, you should know how much it represents. For example, how many small or short lines do we have between 1 and 0? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means one subdivision represents 0.1 of a centimeter. So you know where that goes when it comes to. So please use the correct number of significant figures. This is what you will do for what? This is what you will do for the three rectangular objects. You'll record them as length, width, you'll find the volume in cubic centimeters, and then find the density. This is for the left block, for the middle, for the right block, and that will take care of what? That will take care of the blocks. This is the middle. This is the middle. If I click the middle right here, it will load the dimension. I need the mass, the mass in grams, all right? The mass in grams. And then the same thing you will do for the dimension. This is the length, this is the width, and this is the thickness. You can zoom it if you want to, all right? And record the mass. So I'm gonna go back again, do the same thing for the spheres. I'm gonna do the same thing for the spheres. And for the spheres, you do, for the spheres, you do the same thing. There will be the yellow, which is this one, the black, the green. And if I click the yellow, you should be able to read the diameter scale, the diameter. Again, you should figure it out. What is the subdivision represent? One small line or on the scale represent, what is it, 0.005 or 0.1? You will use that. Now, maybe you have forgotten, but for a sphere, all right, volume of a sphere. All right, let's just of a sphere. This is volume of a sphere is given by volume of us given by 4 or over 3 pi r cubed. R cubed. Of course, radius, if you know the diameter, radius is half, this is the radius. You can find that value if you know the diameter, all right? R equals to D over 2. You divide by 2 the diameter to get the radius, and you plug it in the equation. And of course, this is the value for pi, 3.14. All right, 3.14. And recall the units will be in cubic centimeters, so that when you come to filling in the information, you'll do the same thing. What will be the mass? Or you'll have to read the mass of the yellow sphere, mass of the black and green, the diameter, all right? Of course, you're not gonna use D, but you'll divide by 2 to get the R. This is the equation for finding volume. That's gonna be the volume, and if I know the volume, all right, volume, once you get the volume of the sphere, density is now given by the mass, which you should have, over volume, all right? And you use the previous equation to find. There was this equation right here you will use to find the volume, which will be the value for what? Value for this column right here. You will need to show your calculation. I don't want you to just, fill in some values. You take a snapshot of your roommate or whoever and just try to submit. I will look at the workout. So all your calculations should be attached. I won't be looking at only the table. So bear in mind that I want to see where you apply this equation on your calculation. So that is the sphere. That is the sphere, yellow, black, and green. You'll do that for all the spheres. And then when we go back to our simulation, let's go back to our simulation. You do the same thing for a cylinder. All right. For a cylinder, this is the left one. This is the aluminum right here, and then this is the copper. If I click for the cylinder, all right, I do have the mass, and here is the height and the dimension here, all right, to find the diameter, all right, the diameter of the cylinder. Again, you have to figure it out. What does each one subdivision represent on the metric ruler? Metric ruler for you to find the what? The diameter. Once you figure it out, that volume over cylinder, then we just come here, volume of cylinder, all right? Volume over cylinder is given by, volume is given by pi, which is the same numerical value, r square h, where h is the height, all right? This is the height. This is the height. This is the radius, all right? Radius. Height is just the length, you may call it. And this one is 3.14, the numerical value for pi. This will give you the volume of the cylinder you'll use for all the cylinders, so that when you fill in now, with all the calculation, with all the values you will get, so about that, you will plug in here, what is the mass? You can read the scale. What is the radius? Radius, of course, will be determined by, R will be determined by, again, my whiteboard is freezing, so you divide by 2 that. You divide by 2 the diameter. Once you figure it out that, you will determine or divide it by 2, divided by 2. So when you get to the density, of course, mass over volume, and remember the units, cubic centimeters, pay attention to significant figures. Remember division, multiplication, I walk you through that P4. So these are the cylinders. There is the lead, there is the aluminum, and there is the what? There is the copper on the right. Do the same thing. Please show your calculation. Show your calculation. For the liquid here, all right, there are 3 unknown liquids. If you look at the data sheet, there is the blue, all right, 3, there is the blue, the red or colorless, all right, you'll determine the density of the unknown liquid substances. In the simulation, this is where you will come for the liquids. And if I see this is red, this is colorless, and then this is the blue. If you click on red here, it will take you to the simulation on the determination of volume. First, you'll need to record the mass of empty cylinder. So on the data sheet, let's see, data sheet here. If you see here, mass of the empty graduated cylinder, it's because of this right here. You will need to read the mass of empty graduated cylinder. Mass of the unknown plus liquid. So by here, continue by adding a small portion. If I click here, you will see the portion. If I click here, this is when I want to record this mass. Let's see what will happen. We click here. Now I have now zoomed in the region to read the volume right here is represented by this, and pay attention to where the meniscus is not, you know what I mean by meniscus? There is a curve. Read the lowest point of the meniscus wherever you read the volume. So if I know the volume of the red substance and the mass here, all right, you should be able to fill in the information, mass of unknown liquid substance, of which the difference between the two, mass of the unknown plus the cylinder minus the mass of, you know, the graduated cylinder, empty graduated cylinder will give you the mass of the unknown. So if I may call this 2, call this 1, I'll say 2 minus 1 will give you the mass of the unknown, all right? Mass of the unknown. And the volume here in ml is what you read on the lowest part of the meniscus. And of course, the units will be in ml. You'll have to use the density formula to find the mass, I mean to find the density of your unknown liquid substance. All right. Let's see, if I continue adding another portion. When they say continue by adding another portion, it's the same. You see portion 2 by adding. Let me just click that again. Let's see what's gonna happen. You see it was here P4, right? All right, suppose we add. So you'll have to do it over again, and then every time you click another portion, the volume will change, the mass will change. The volume will change, the mass will change. You use the same format in what? In determining the mass of your unknown liquid. You will do here, I didn't mean to do that. You will do the same thing for portion 2, portion 3, all the way until you have all, let's see, all the 5 portions. You'll do all the 5 portions. You're gonna do the same thing for colorless. You will do the same thing for the blue substance, for liquid substance, for the liquid. Now, once you are done with that, you will do the same thing for what? The pennies, except that it is slightly different. For the pennies, you will have to pay attention to the pennies. So I'm gonna do simulation for the pennies. This was a little bit tricky. Pennies right here. So what are we going to do here? I don't want you to do all of them. Again, you will do 1980, 1981, 1982, 1983, and 1984. Don't do 85, do not do 86, do not do 87, do not do 88, do not do 89. Determination of a penny, density of penny. So where is our data sheet? This is our data sheet down here. Let me bring down here. For some reason, my whiteboard is not working. So anyway, if I want to find the density of the pennies, I'm just gonna come here, all right, and click for the 1980. 1980, I have what? I have 3 stacks. This is stack number 1, stack number 2, stack number 3. This is for 1980 though, all right? So you need to record the mass of each. This is stack number 1, stack number 2, stack number 3. Let's see the data sheet. On the data sheet here, all right. Remember, I clicked 1980. It is showing me 1980 here. So stack 1 is right here. So it's just gonna be what? Mass of 1 stack for 1980. There is 1980. What is the mass? It's gonna correspond to this. This is stack 1 for 1980. If I come to stack 2, this is stack 2 right here. Look at my cursor key. Stack 2 for 1980 will come here. And for stack 3, all right, for stack 3 of 1980, it will, I'll record the mass down here. You see how you record the stack? Stack 1 for 1980, stack 2 for 1980, stack 3 for 1980. So every stack corresponds to different years, all right, or different rows. Stack 2 will be on this column. Stack 3 will be on this one. And the masses, you will read from the scale. Now the volume here is, if I click here, this will be what? This will give me the volume of 1980. This is just empty. It's just gonna be start from stack 1 here. Look at the data sheet. The data sheet here for stack 1. This is a stack 1. This is just the initial volume. All right. First volume reading, second volume reading, volume of the stack. So this is the initial volume reading. For stack 1 for 1980, remember we are in 1980 here. For stack 1, first volume reading is right here. Second volume reading is, after you put in there, is just gonna be the second, right? So what will be the volume of the stack? This is the first volume. So for stack 2 here, it's gonna be the same initial. Remember, we are reading for 1980. So for 1980 for stack 2, I'll use the second or the middle final volume. This will be your initial volume for all of them. So for 1980 stack 2, initial volume is right here, final volume is right there for stack 2. And then on the data sheet, still on 1980, remember we are still on 1980 right here for step 3 here, the initial volume, the final volume, all right? Final volume, you got to read from here for stack number 3 for 1980. That's what you will do for each stack. So once I'm done with that, you will just come and say continue by collecting data from if you want to, but for other years right here is you will fill in 1989. If you click here, it's gonna give you for the other years, all right, your data for 1980. You don't need to do this, somebody has to do this. You're gonna fill in for your case. So you'll do once, somebody else will give you that. Let me go to 1981 and then gonna show you how you do. So 81 here. So we will come back to 81. On the data sheet, this is the data sheet right here. So I'll just come here and say 81. Stack 1 is what? What is the mass of stack 1 for 1981, which will come down here? Read that. For stack 2, what is your mass, which will come down here? For stack 3, you'll record it down here, stack 3, all right? So to get the volume, just click right here, and the initial volume is here. The final volume for stack 1, for stack 2, for stack 3. You record the initial volume, final volume. What is the volume? And then you find the density, of course. Stack 2, stack 3, and so forth. Now, for the rest in 1981, all right, 1981, you will click, see your data, 1981. You have your data here, 1980, somebody had to do that, but you'll only have to do 1981. You'll have 8, you'll only collect yours. So if I have 80, if I have 81, the rest 81, 82, 83, for the rest you're just gonna fill in. Say 84, you're just gonna fill that. You do the same thing for what? You do the same thing for 80, 85. So if I click here, 82, for stack 1, all right? Stack 1 is what? Stack 1 is for 1982, stack 1, what is the mass? It's just gonna fill in here. To get the volume, first volume and second volume, I'll just click here and do what? First reading, second reading, second volume to get the volume of the stack. And if I know the mass, or you know the mass, you divide by the volume to get the density. So you'll do the same thing for stack 2, 2 stacks, or stack 3. 1980, 1983, 1984, you know, I don't want you to, you'll just collect the first 5 for your case. Don't fill in using other people's data, but you will be collecting yours, 83. I'm gonna do the same thing. I'll go back again, 84. Until 84 here. Do not do 85, don't do 85, 86, 87, 88, 89. So I'm just gonna cancel 85 all the way to 89 by collecting your own. Don't fill in, or when you collect the first, this will be your own data. The first, the first 1982, 81, 82, 83, and 84 will be your own data you will collect from the simulation. You will collect the first, again, let me repeat, 1980, 1985, 1980, 1980, 81, 82, 83, 84, and 85. So how about 86, 87, all right, 87. Do not do those, just do 85 up to 85. The rest, you can just leave it blank. That is enough exercise for determination of the density, all right, determination of the density of pennies. Other than that, if you have any question, you can send me an email. I'll respond, or I will schedule a Zoom meeting with you to walk you through the calculation if need be. So remember to turn in your work via Canvas. You know how to do that. You need to go in Canvas and you'll submit your work through Canvas by just clicking on the lab. You'll have to go to the lab data sheet here, all right? And there is a document you'll have to, same document you can download and use the submit button. There is a submit button at the top, which you'll have to come in once you click, once you download. You won't be able to see from my end. If I change here to student view, then things will change a bit. Things will change a bit in the sense that I'll have density of solids. This is the lab, all right? And this is where you will have to come and submit your work. You'll just click submit and attach your work wherever, wherever it is, like browse and look for where you save your document if it is on desktop, and then click submit. Please make sure that you pay attention to the rubric. There is a rubric for each lab. If you don't show the calculation, you lose a lot of points, about 30 points. How do you end up with those values? With that, that marks the end of what I just wanted to highlight as far as the lab is concerned. See you next time. Be checking your emails. I'm gonna post more information on Canvas if need be. Thank you.